Good afternoon, everyone. I hope that everybody's doing great today and that you had a wonderful weekend. We're going to be looking today at lesson 30.17, which deals with horizontal asymptotes, and this is on page 7 of your current lesson handout. It's a very, very short lesson. We're going to be learning what a horizontal asymptote means and how we can find the equation of the horizontal asymptote or the location of the horizontal asymptote using a couple of different methods. So to begin with, what a horizontal asymptote is something vertically that the function approaches as x gets very, very large. So a horizontal asymptote exists if the value of the function, if the value of y, which is a vertical measurement of the function, approaches a constant value as x gets very large. The key word here is approaches. This is a picture taken from the previous lesson that we did when we were talking about holes and vertical asymptotes. And you can see here that there is a horizontal asymptote, and the location of the horizontal asymptote, which I'm pointing at right now, is y equals 1. There's a horizontal asymptote at y equals 1. There is also a vertical asymptote at x equals -2, but I'm really not too concerned about that. This lesson is on horizontal asymptotes. So the reason why the horizontal asymptote exists is as x gets bigger, y gets closer to 1. It doesn't matter whether we look to the left or to the right. As x gets really, really big in a negative direction or really, really big in a positive direction, it will get closer and closer and closer and closer to having a y value of 1, but it will never reach 1. So let me repeat that. If there's a horizontal asymptote, that means when x gets really, really big, y starts getting closer to some number. And if you understand that idea, then you can use it to determine where horizontal asymptotes exist. Let's take a look at the examples we're going to be doing today now. We have this function f of x equals 3x minus 10 over 2x squared plus 35, and we're asked to determine the equation of the horizontal asymptote if it exists. Well, what we're going to do is use our graphing calculator to evaluate what this expression is equal to for large values of x. Remember that we've just said with a horizontal asymptote, as x gets really, really big, if y starts approaching something, then that thing that it approaches is where the horizontal asymptote is. So we're going to put this function in for y. We're not going to look at the graph. Don't look at the graph. We have to put 3x minus 10 in brackets, divided by, in brackets, 2x squared plus 35. We're going to go to the table. We're going to set up the table to start at 0 and go up by 1. And when I go to my table, I can see the value of y when x is 0 is about -0.29. And as x gets larger and larger, y starts getting smaller. When x is 15, y is only 0.07. Remember that a horizontal asymptote exists if, as x gets bigger and bigger and bigger, y approaches something. Now it's pretty hard to see whether y is actually approaching something here or not. So what we can do is we can go to our table and we can change the independent to ask. And by the way, how we're answering this question is a very clunky method. I will show you a different method in a second. So when I go to my table, after changing the table set to ask, it's waiting for me to input an x. Well, I want to look at large values of x. So I'm going to put in 1,000 for x. And when I put in 1,000, y is 0.00149 something. When I put in 10,000, which is an even bigger number, y is 0.0001499, and it keeps getting smaller. As I increase this to larger and larger and larger and larger values of x, the y coordinate gets smaller and smaller and smaller, but it never reaches 0. So we conclude something here. We conclude that there is a horizontal asymptote at y equals 0. As I've said, this is a very clunky method. Before I give you the rule and we finish off the other examples, I'm going to take a look at what the graph looks like. So this is the graph of the function. 3x minus 10 over 2x squared plus 35. And there is a horizontal asymptote at y equals 0. You can see, looking at the graph, that as x gets bigger and bigger and bigger in the horizontal direction, y gets closer and closer to that dotted line. On the left-hand side, as x gets bigger and bigger and bigger in the horizontal direction, y gets closer and closer to that line. So the line y equals 0 is the horizontal asymptote. So number 2, let's use our graphing calculator to figure out what the function approaches when x gets very big. We have 5x squared minus 2x minus 9. You have to make sure you put that in brackets, divided by, in brackets, 2x squared minus x minus 10. And the bottom has to be in brackets as well. So if I go to my table and I take a look at x equals 1,000, you can see y equals 2.5003. When x is 10,000, y is 2.500025 something. When x is 1,000,000, y is 2.500000250001. It's appearing as though as x gets very large, y approaches 2.5. So we conclude that there is a horizontal asymptote at y equals 2.5. Here's the graph of the function we were just talking about. Now, there is a pair of vertical asymptotes, but again, we're not concerned with that here. This is the line y equals 2.5 that you're looking at, the horizontal line. And you can see that as you move to the left or to the right, as x gets very large in either direction, y starts approaching 2.5. And 2.5 is the location of the horizontal asymptote. Take a look at 3. Again, we're going to use this clunky method, and this will probably be the last time we do it this way, because once I show you the rule, I think you're going to want to use the rule. We have x squared plus 2x minus 24 divided by 2x minus 5. Go to my table, and when x is 1,000, y is about 502. When x is 10,000, y is 5,002. Then at 1,000,000, it's 5,000,002. This is different than what we were looking at with the other two examples. In the other two examples, the value of y was, I guess the best thing I could say is the value of y was settling down. It was getting closer to some number. Whereas here, it appears as though the value of y just keeps getting bigger and bigger. And when that happens, what we say is there is no horizontal asymptote. There is a picture of the graph, and we want to focus our attention, everybody, on this part of the graph here and on this part of the graph here. Because as x goes further and further in this direction, what happens is y keeps going up. It never settles down. Over here, as x goes further and further in this direction, y keeps going down forever. In other words, this graph goes up to infinity on the right and down to negative infinity on the left, so there is no horizontal asymptote. There is, by the way, a vertical asymptote, but again, that's not important for our discussion. So our statement that I wrote here that says no horizontal asymptote is true. Now, what's the rule? Before I tell you the rule, I will tell you that to use the rule, you have to focus on the highest degree term in the numerator and denominator. So when you look at the numerator of example 1, the highest degree term is 3x. Highest degree means the one with the most x's. In the denominator, the highest degree term is 2x squared. In example 2, the highest degree term in the numerator is 5x squared, and in the denominator is 2x squared. And in the third example, we have 1x squared as the highest degree term in the numerator and 2x in the denominator. So here is the rule. If that numerator highest degree is bigger than the denominator highest degree, then you have no horizontal asymptote. In fact, that was the case here. The degree in the numerator is 2, the degree in the denominator is 1. When the degree on the top is bigger than the degree on the bottom, this will always be true. If the numerator degree is less than the denominator degree, then you will have an asymptote at y equals 0. In fact, that's what was going on in example 1. The degree in the numerator was 1, the degree in the denominator was 2. 1, which is the numerator degree, is smaller than the denominator, so you get the x-axis being an asymptote. The third part of this rule is for what happens when the degree in the numerator and the denominator are the same. If they are the same, then the equation of the horizontal asymptote will be y equals the ratio of the coefficients. That was example 2. And in example 2, the degree on the top was 2, the degree on the bottom was 2, which means if the degrees are equal, the rule says the asymptote will be equal to the coefficient of the top over the coefficient of the bottom, and that's 5 over 2, and by the way, 5 over 2 is 2.5. And that's it. I think if you use these rules, if you can memorize rules, and I'm not a big memory person, but if you can memorize the rules, it's a lot slicker than putting these into your calculator and trying to figure it out by looking at the graph and looking at a table of values. Anyway, that's it for today. You have 12 questions on the next page which require you to determine whether there is a horizontal asymptote or not, and if there is a horizontal asymptote, what is the equation? Again, I would use those rules. I think the rules are the quickest way that you can get this done. Anyway, I hope that made sense, and I hope that you have a wonderful rest of the day, and we will talk to you soon. Take care.